Hello, welcome to the EES tutorial video. First thing I'm going to do is I'm going to get into Citrix, and I showed you how to do that in class. Okay, so for me it's a little bit easier than for you. I just click on here. Now, we all got to this point where you show up to the USMMA Engineering Applications. Click on this thing, and then you just have to wait a little bit. Still waiting. Okay, so you can see that your screen looks different now, and it's not done yet. But you can see EES is here on the left, and I got some other software here. You'll be using this one in Fluids. So just click on EES, double click, and wait a second. This should be pretty fast, and here it is, it's coming. Okay, just hit continue, and there we are on the EES screen. Okay, so the problem we're going to be solving is the problem we did in class of refrigeration cycle. We're going to find its coefficient of performance. And first thing I want to do is to set all the options that we need. Go to unit system first, and I'm just going to change it to English units or US units. It's going to be per unit mass, BTUs per pound mass instead of per mole. It's going to be Fahrenheit, and PSIA will be pressures, and any degrees are going to be in just degrees, not radians. And if you come down here, you can also set units automatically when possible, so it'll actually calculate units for you as you're multiplying things, or dividing. And here, and then we just go to display. I just want to make it a little bit bigger so you can see it better. So I'll just increase that to 12, and then we just hit OK. All right. So now I'm going to start. I'm going to put some comments. See those two slashes is a comment statement. So the problem we're going to do is, first of all, we're going to have a point. So we're going to have H1 is going to be the enthalpy at inlet of compressor, right? And the temperature T1 is going to be 30 degrees Fahrenheit coming into the compressor. All right, and then at exit of compressor, so compressor exit is going to be H2, will be enthalpy compressor exit, and slash, it's the condenser inlet, right? Inlet. So that's T2 is going to be 30 Fahrenheit, and we're going to say that the entropy at 2 is equal to the entropy at 1. In other words, the compression is happening reversibly and adiabatically. In other words, no friction, no heat transfer. In other words, isentropic. So that's point 2. And then point 3 is going to be the enthalpy at condenser inlet, condenser exit rather, exit, and we're going to say that it's going to be a saturated liquid at the exit, and we're going to say that P3 is equal to P2. All right, so the pressure through the condenser is going to remain the same. So in other words, the pressure here, P3 is going to be equal to P2. One thing I forgot to tell you about point 1, I'm going to add to it, is that it's a saturated vapor at the compressor inlet. And then H4 is going to be after throttling, right? Throttling, and after the throttling, and then it's going to drop to, so it's throttled down to T1. Okay, so in other words, T4 is going to equal T1. All right, so so the governing equation for throttling again is H3 is equal to H4. All right, so let's start then. So we're going to start at the compressor inlet, and we're going to calculate the enthalpy H1. So this portion here is the variable name is, this is something you can choose your own name. You can call it write out enthalpy 1 or write I love lunch, whatever that can be your name, as long as it's not all numbers, right? So H1, so now we're going to give it the name of what we're looking for. There's a built-in function in EES which is going to calculate the enthalpy for you. And the first thing you have to give it right after that is the substance you're working with and two properties. Because remember, with two properties you can calculate all the other ones. So at the inlet we know that T will be equal to 30. And you can put in the Fahrenheit here, right? Put in the units. And we know the quality is equal to 1 at the inlet. So there you go. Now there's alternately, you could have said, you could have done this. You could have said T1 is equal to 30 and put the units here, right? And instead of saying T is equal to 30, you could say T is equal to T1. That would work just as well. All right. All right. So there's the enthalpy at 1. Now let's give it the entropy at 1. Again, that name S1. You can change it. You can use a different name. So there's a built-in function that calculates the entropy, and it's called entropy. Type in the name of the substance you're working with. And by the way, EES is not case sensitive, so uppercase or lowercase doesn't matter. T is equal to T1, X is equal to 1, right? So now we've got that. And let's say that you wanted for some reason to have the pressure at point 1. I'm going to call that P1 is equal to, well, you want to know the pressure. It's got a function for finding pressure. And R134A, T is equal to T1, X is equal to 1. Okay, so there you go. There we go. There's all the things that we need at the compressor inlet. Now let's do compressor outlet. You don't need all these comments, but it just makes it look nicer. You show off a little bit to your friends. So we need the enthalpy. H1 is equal to enthalpy. See how easy it is? It's just the same thing you did before. In this case, T is equal to 200 Fahrenheit. Okay, that's a specification. I forgot to tell you at the... Ooh, I wrote this wrong. T2 should be 200 up here. Okay. So T is equal to T200 and S is equal to S1. Okay, so you found S1 before, and it knows when it hears T that's a temperature, and when it hears or it sees S, that's entropy. We can put the units here just so it'll keep crunching them for us. Much nicer that way. And let's see, you want to know the pressure at compressor outlet. Wow, that should have been 2. Making lots of mistakes. So so let's say we need the pressure at 2. You know how to do this already, right? There's a function for that pressure. R134A. T is equal to 200. F. S is equal to S1. And there you go. You got it. Okay. So we got now the compressor outlet, and now we're going to move on to the so the compressor outlet is the same as a condenser inlet, right? So now we're going to move on to the condenser outlet, which is also the TXV inlet, right? Okay, TXV inlet. So we know that P3 is going to be equal to P2. Okay, that's the way we're modeling this. We're modeling no pressure drop through the condenser, which is not a bad approximation. And oops, P3 is equal to P2. So we want to know the enthalpy. H3 is equal to enthalpy R134A. T is equal to, not T is equal to, X is equal to 0 because it's a saturated liquid, right? We specified that at point 3, it's a saturated liquid. X is equal to 0, and we need another property, and we know the pressure. P is equal to P3. We could have said P is equal to P2, same thing. Okay. So there we go. So now we've got the enthalpy there. So now we know the TXV outlet, which is same thing as the evaporator inlet, right? Okay, so we've got then, all right, so we know that H4 is going to be equal to H3. That's just what throttling is, right? H4 is equal to H3. And now we want to know and we know that T4 is equal to T1. And that's a given because we're throttling it down to the same temperature as T1. So we just get the enthalpy. Oops. Say H4 is equal to then enthalpy R134A. H is equal to H4. T is equal to T4. T1. Oh yeah, T4, T1, same thing. T4. And so that's everything. So now we're just going to calculate the coefficient of performance, the COP. And remember, it's your useful output over your COP then. There's no function for this. Calculate it yourself. It's easy enough. So it's going to be the useful output, which is the cooling that occurs in the evaporator, right? So this is going to be the evaporator is going to go from 0.4 to 0.1, right? So I wish I had a diagram right now, but okay. Just to use the same diagram we had in class. So it's going to be the useful output, which will be H, parentheses here, which will be H1 minus H4. Right? This is the heat gained in the evaporator, right, by the refrigerant. And then we divide that. I'm going to take the absolute value, so this will be the work done, put into the compressor. So I take the absolute value because it'll give us a negative number, and I want the coefficient of performance to be positive. So the absolute value, then the work through the compressor is going to be the difference in enthalpy through the compressor, H1 minus H2. And I believe that's going to do it. If I hit F2, it'll solve it for us, and hope to see if there are any mistakes. It'll tell us to hit the run button without any fear, and F2 will run it. But if that doesn't work for you, just hit that calculator icon, and that'll do it. And here's something it doesn't like already. Oh yeah, look at this. I said H4 is equal to the enthalpy. Aren't there? H is equal. We know H4. We don't need to calculate it. That was dumb. It's equal to H3. That's calculated up here. So F2 runs it, or use a little calculator icon. And there we go. We got everything in there. Let's see if these are reasonable values. Coefficient of performance, that's what we got in class, 1.423. Everything looks good. So, by the way, if you ever need to get back to the equations, use this little equation icon here. All right, equation icon. And let's say you wanted to calculate the quality at 0.4. There we go. So let's say x4 is equal. So there's a function for quality, and you guessed it. It's quality R134A, and just give it two properties. T is equal to T4. H is equal to H4. Let's see if it likes that. It should be perfect. F2. And there we go. Quality is equal to 0.6595. No unit problems were detected. See, it gave us all the units for everything. So there it is. It doesn't get much better than that. So it's a good place to stop. Oh, and by the way, you can save things in EES by going to File, right? And then Save As. You can't save it to your PC apparently because you're in the. When you're using EES, you're actually using the Academy's servers. So your actual computer won't show up here. So what you have to need to go is go to your network. I happen to have a network here, which is my, I think it's the iDrive. iDrive, and save it there. Now, I think it's just lagging a little bit. Or maybe I just didn't hit the buttons hard enough. Oh, I'm already there. Okay, good. And I'll just pick a name for it. My first EES program. Okay, it may be a little long, but save. and now it's saved, so you can go back to it. Okay, so that is that. So now we can just get out of EES and disconnect from here, and now we're back. I'm going to be back. Now we're back to my screen, and I can just stop the screen recorder. Goodbye.